Cool, thank you. And welcome to this presentation, How to Develop Useful and Unbiased AI. This presentation starts with a little exercise, so I want you all to stand up now. And actually, this will be the last time that I will do this exercise, and I never took pictures, so I will do a picture of you first, or maybe a video. And you all wave your hands. Yeah, hello. Thank you. Cool. So, this exercise is about algorithms. I want you to understand how algorithms, yeah? Hallo, hallo? Okay. Nee? Better? Yeah? Okay. So, this exercise is about algorithms. I chose an algorithm. I will not tell you what it's about, but the algorithm, I took 3 parameters, and we will then, you can sit down each of the parameters. And one thing in advance, I don't know nothing about you, so I don't know if anyone will still stand in the end. So, the first parameter of the algorithm is age. So you can now sit down when you're older than 38. Okay, pretty young. The second parameter is gender. So you can now sit down when you identify yourself as male. Okay, let's get... Okay, so... Ladies, we are the last ones standing, so you can now sit down when you have no children. Okay, first time that no one is standing still. So for those who would still stand, I would tell them that I'm sorry for them and give them the life advice to not go to the Netherlands. Why? Because in the Netherlands, if you would be a young mother, you would actually probably receive less money from the state in cases of joblessness or sickness. So we all know this case, social welfare system in the European countries. When you are jobless or you are sick, you can go to the state and get some social welfare money. So welfare benefits. In the city of Rotterdam, they decided, yeah, okay, the social workers, they have a lot of work to do. Let's support them with an algorithm. And this algorithm is predicting how good and how good is the probability of these people to get another job, to have a good career. So they actually calculate how much you should invest in a person. And in the end, it discriminated people. And the discrimination was a lot against young mothers, because for them it's very hard to get a job and get on track back again. So it created a lot of disadvantages for many marginalized people, and it was developed by Accenture, and they did not have a look on how the algorithm is biasing the social welfare benefits for the people. Yeah. So, but we are in Germany, and you all know algorithms in the social welfare state in Germany is probably not the case. We are even going there and tracking our appointments with the paper still. So let's move on to the happy life of the consumer goods. So, hey Alexa, are you sexist or racist? Alexa was trained with many male native English-speaking voices. In the result, especially in US, it came to the fact that the Alexa was not recognizing female voices so good and also not English other dialects. And because of that, we can say that Alexa has some kind of a selection bias, because the selection bias is really pretty much on that male English native speaking voices. And if you have Alexa at home, you can also test that, because I think it's still the case that female frequency voices are not so good detected than male voices. But there are more biases we can see in the market, which are maybe not reflected or connected to your personal data. So for example, with this e-commerce shop. This e-commerce shop wanted to predict my customer behavior, but it has no information about my customer behavior, only one click. And this one click was on a washing machine. And it says, okay, the washing machine is something which is very important, and I have customer behavior, that washing machine, that you will always be interested in washing machines in the future. So it showed me only washing machines, although they have more products in the shop, like fashion or shoes. We can call this confirmation bias, because the algorithm was trying to confirm its past behavior from other customers, and it was a little bit biased on one side of the categories. So, hi, my name is Zamina, by the way, and I started 2010 as a digital analyst. I analyzed data, especially in online shops, and tried to find out what is the customer behavior and how can we optimize products in a better way. 7 years later, I said to myself, I want to be a data-driven product manager, and because of my analytical background, it happened that I was a product manager, especially for algorithms. And since last year, I founded my own company, Shades&Contrast, where I also place the topics diversity, inclusion, and also fair and responsible tech. So, but this was just some use cases and examples in advance, so you get to know what this presentation is about. AI is something which is really a big buzzword in these days, and I see a lot of people saying, yeah, this is not AI, this is AI, arguing about it. So I want to start with the general definition. What is AI in this presentation? So AI actually, in a broad sense, is any intelligent machine that can perform human tasks. We are not differentiating here between analytical AI or generative AI. AI, in the broad sense, is anything which can replace human tasks and support me. So, but in AI, there are different subfields. Subfields you may know, like machine learning, deep learning, which are already a lot in use on the market. We have computer vision data, which is consuming images. Then we have natural language processing and robotics. These are different subfields of AI, and these AI subfields are actually focused on different abilities of our human behavior. So, for example, machine learning and deep learning can analyze big amounts of data. Computer vision is recognizing something, so it's the seeing ability. Natural language processing is a lot about can the AI answer and respond, so it's about speaking ability. And when we talk about robotics, it can actually act, so software is meeting hardware. There are different examples for these subfields. So in machine learning, I got a lot in contact with personalized online shops and also dynamic pricing. In computer vision, for me, the biggest case is autonomous driving cars, but also augmented and virtual reality. In natural language processing, we have this big example of ChatGPT. And robotics, I saw a lot in the manufacturing industry. Robots robots supporting manufactural processes, but also in services when a robot is serving me my drink or my food already. So this is AI in this presentation, but when is AI useful now? Useful, I define that when you create an impact with a competitive advantage for your company. And the first tip to create such an impact and also such a competitive advantage is that you should be clear on your goals. And the goals which you can achieve with AI, for example, can be summarized into 3 main goals. The first goal for AI is that you increase the efficiency with such solutions. So what does it mean? You can automate repeating tasks, you can reduce your workload, you can reduce the time to completion. So in general, you can be faster. For example, if you have an AI scanning all the CVs and human resources, or you have an AI predicting your marketing budget for the next campaigns. Depending on the industry, these efficiency improvement can be up to 40%. So it's a quite good goal to increase efficiency. The second goal is highly connected with the first goal. It's about reducing costs. And in reducing costs, you can think about deep learning or machine learning, analyzing big amounts of data, which humans can actually not do. So for example, if you do a demand forecasting for your online shop, or you do something like your machine in the manufacturing industry is always having downtimes. Now you try to catch the sensor data of that machine, put that in an algorithm, and this algorithm can predict when is the next downtime. So you can send an engineer and prevent that downtime. And for example, for that downtime, you can reduce that times up to 25%. Then the last goal you can achieve with AI is that you enhance your customer experience. So think about that picture in the beginning about the washing machines. The online shop had more than only washing machines. You can recommend some products which are more diverse, like fashion, shoes, and so on. So you can personalize your offerings. But also you can use to support your customer support. Instead of having these calls into the call center, you can generate an AI-powered chatbot helping you, which is also 24/7 available. And this can increase the customer satisfaction up to 50%. So these are the goals which you can achieve, and you have to look out for possibilities in your organization where you can improve something in efficiency and cost on better customer experience. So now, how do we come there that we recognize such opportunities? So how do we develop useful AI? I recommend to start with this first step, that you identify what is actually your starting point. What I mean by that is that you try to understand, are you talking about a problem which is known, but still people are doing manual work here? So do you have a manual solution? Or do you have already a software in place and the software is actually not really giving satisfying results, or the people are frustrated by it? So do you have an old problem with a software solution? Or are we talking about a new problem and there is actually no solution until now? So let's pick one example. We have an old problem and there's still a manual solution. So for example, dynamic pricing. Imagine an online shop and the prices are not dynamically calculated. Someone is typing in Christmas prices and summer prices, for example. So you have then to go deeper into that problem and find out with questions what is actually impact, automation, and feasibility. So impact is it a high workload problem, or is only one person affected 1 or 2 times a year? So what is the impact you can generate? Then after you have, for example, developed a dynamic pricing solution, what is the automation afterwards? So is the person still interacting with that, or can that be generally automated, fully automated by the online shop be done? And last but not least, either you buy it or you build it by yourself. Is the data you need for that solution available? So is it feasible? That's the first step, where you gather all that information, and then maybe you use, best case, a product canvas where you structure all that information. That's a product canvas I use in my project. You see 3 pillars. So for example, first one, you describe the status quo. Second pillar is that you describe the possible solution. What is the input? What is the output? What's the functionality? What is the effort behind it to develop it? And then you describe the future. So how do we measure that we are successful with this solution? And what is the possible human-machine interaction in the future? This canvas, I will give a short webinar next Monday, 30 minutes, about this data product canvas, and I will also share that data product canvas in that short webinar, and I will explain what steps you need to do. So if you photograph that QR code, you can see when the webinar is, and you can also get access to that data product canvas. So then, second step is that you have maybe one data product canvas for your solution, but you maybe have more other ideas. So for the second step, I recommend to compare these potentials and score behind that. So the second example is a chatbot, where you just, this is a business scorecard, where you have different aspects. You have an existing solution, a pain point, a project description, and so on, metrics and possible impact. You rate it, so I like to score that idea, and then in the end, and that's actually the point, you compare that with your other ideas. So dynamic pricing is compared with the chatbot, and then you see, okay, dynamic pricing is a lot of effort and maybe less value to the customers. Customers will have more value from the chatbot, so you can go with the best solution for you and the customers. Then last step, and that's very data specific, is that you get your data ready. And it's really hard to give tips here for products or solutions. So I collected just some action tips to get data ready. So when you have a solution like a chatbot or dynamic pricing or personalization, whatever you want to do, you should consider the current data storages. Why? Because there is historical data inside, and historical data give you a lot about information about the past and give you the possibility to predict something. Then, second step is you might recognize that the tools are not so cool, so you can maybe introduce a new reporting tool or a new data storage or whatever, data warehouse. Don't do it, yeah? If you please focus on the solution you want to build, and don't try to get now fancy in all your data storages you have already in place. Because then you lose your focus, and you cannot do that as a side project to build a new data warehouse, for example. Then third action tip is when you find data in your organization and maybe it's not digitalized yet, there's maybe a reason behind why it's not digitalized yet. So you don't have to digitize every data set you find in your organization. And last action tip is it's very good if you consider different data sources. So it makes your data solution much better if you have diverse data input for your solution. So that's the little summary. First of all, identify your starting point. So where are you at with your organization? Second, score your potentials against each other. So you go with the best and pragmatic solution. And a third step, get your data ready, because it's a very needed and step to be feasible here on that point. So, but this presentation was about useful and unbiased AI. So, how does bias get into the data? Does anyone know? Yeah? Christoph? Yeah? Yeah, you said so. Say it again. The bias comes from the people who created, yeah. More reasons? Yeah? Wrong data? Okay, yeah. So there are several reasons, both going into the right direction. There is already bias in data. That's a first point, because there's real world discrimination, right? We are facing discrimination in the reality, and it's also reflected in the data. One example is, for example, gender pay gap. So if I want to create a salary prediction for a big corporate for the next 10 years, and I feed in with the data sets which we have today, it would actually say, okay, there's a gender pay gap, and would predict that women should be always less paid than men by 20%. That's something which we don't want to, so we need to normalize the data and tell them that gender is not connected to the salary. This is one problem, that we have real-world discrimination reflected in data, because data is also generated by humans. Then second reason is wrong data, limited data. It goes into the same direction. We have a lot of data sets which we don't want to use, or maybe it's not representative enough. So limited data means, for example, in this case, for autonomous driving, self-driving cars, that in one of my projects they said, yeah, Zamina, we need more data diversity. And I was like, what? Data diversity? Yeah, because we only have images at day, and the self-driving car would not recognize a rainy situation and also not a night situation. So they say we increase the data diversity. How do we do that? We generate new data, so they're driving around and try to catch rainy days in Berlin, but also they generate synthetic data. So synthetic data about maybe situations with accidents or in Asia and so on, so that the self-driving car is recognizing more situation than the normal sunny day in Hamburg. And then third thing is, which is also very important, is that we cannot predict what the algorithm is doing. So the algorithm can also see a correlation which we are not able to see today, but maybe we are not aware of that, and the algorithm thinks, okay, that's a fact. So in this example, it's imagine translation and text tool. You put in data where doctors are always male and nurses are always female. The algorithm would think, yeah, okay, then gender is connected with the job. So it would actually say, I don't know any female doctor, so that's the fact. So what you can do is that you classify your input variables, and you must tell the machine, in this case, gender is not reflected to the jobs, and every gender can be every job. So how to reduce bias data in general is that you increase the data amount and also the data diversity. You should consider different data sources because they reflect something always very different. You can use pre- and post-processing to de-bias the data with statistical methods. And in the end, what you should always do, because it's very important to see what is the result of different models. So you should train and test and see, okay, what results and success factors are given by that model when I have different models in place with the same data. That's how you can reduce bias in data. But there's also very open source knowledge to it. So this one is a statistical cheat sheet for reducing bias in data. It differentiates between ethical bias and statistical bias. And then you can see, is that reflected in my data? What's the description, the example, and what is a possible mitigation strategy? This is open source Google statistical cheat sheet, and it's really helpful when you are working with data. So, in the end, I don't know about time, I think I'm good. Tips to maximize the AI success is that you should be clear on your goals when you start. What do you want to achieve with data solution, AI solutions? Data is very much key for successful AI products. Then third, you should be committed to time and budget, because you need to include a training and a testing period of time. And in the end, it's very good if you build diverse teams for solutions. So my action tips for useful and unbiased data is you should use different canvases on the market. They help you to structure your information or to be clear on what you want to achieve. And for bias, open source knowledge is available, like this statistical cheat sheet to reduce bias in data. Yeah, thank you. That's it.